Welcome to your notes on feedback loops. This is a follow-up for the activity that we did last class. Now, as far as taking notes, I'm going to talk about two of the loops that were in your activity. You do not need to draw those, although you can if you want, but I would like you to draw the generic feedback loop that I'll talk about at the end. Okay, one of the feedback loops that we discussed in your activity is body temperature. Now, remember, feedback loops help maintain homeostasis in the body, so they try to keep things the same, maintain stability. And if your body temperature gets too high, then your brain, which is monitoring the situation, will send out signals to lower it. Now, in the case of humans, lowering your body temperature involves sweating, and it involves dilating your blood vessels, which means that you get flushed. And if you get flushed, you may have noticed that your skin feels warm to the touch because you're releasing heat to the environment. And that way your body temperature lowers and you maintain that stable body temperature. Now, if your body temperature gets too low, your brain has a slightly different reaction. It sends out different signals. And in the case of humans, you will start shivering, which will warm you up, and your blood vessels will actually constrict, which means you'll look very pale. If it's very, very cold, maybe you could even get frostbite because you don't have blood in your extremities, but it does conserve heat and make it so that your body temperature can stay more stable. And that's the way that your brain will actually maintain homeostasis in your body temperature. Now, your blood sugar is similar. So your blood sugar is the glucose levels in your blood. And if you've just eaten a lot of sugary food or, anything else that would put a lot of sugar in your body, generally eating stuff, your pancreas, which is the thing that's in this case, it's monitoring the situation, it's going to release a hormone called insulin. And insulin you may have heard of before because people who are diabetic either don't make insulin because they have type 1 diabetes and their body has attacked the cells that make insulin, or don't actually react to insulin the way they need to, and that's what type 2 diabetes is when you get it as an adult. Either way, the reason why insulin is so important is because it tells your body to actually take up more sugar from the blood, and most importantly, it tells your liver, hey liver, we need to store some of this extra sugar, and it stores it as a carbohydrate called glycogen. So that will lower your blood sugar to a more acceptable level. Now, the other thing it will do is reduce your appetite, so you're not eating so much, your blood sugar won't go up again. Now, if you have really low blood sugar, your pancreas has a different reaction. It releases a different hormone called glucagon, and glucagon will actually tell your liver that stored the sugar before, hey, we can release some of that sugar now. And it will also make you hungry so that you'll eat and raise your blood sugar. Blood sugar is not maintained within such a tiny range as your temperature, but it is always maintained in a relatively small range because your body doesn't deal well with very low or very high blood sugar. It needs to have that homeostasis. All right, now this is a generic feedback loop that I would like you to draw in your notes. So this is in general, if you have a condition that's controlled by homeostasis in your body, if it gets too high, then some sort of receptor, this might be something like the brain or the pancreas or some other organ, that will monitor the situation and say, oh, it's too high. So they'll send out a signal and cause a reaction, a response that will lower the condition. Remember, so that we maintain that stability, that homeostasis. On the other hand, if your condition is too low, the receptor will send out a different signal that will cause a reaction, a response that will raise that condition. So this is the generic idea of a feedback loop. Now remember, this is a negative feedback loop because all of the feedback loops that maintain homeostasis are negative feedback loops, not positive feedback loops. Positive feedback loops don't maintain stability, they cause an increase in a condition. And we talked about how those do happen in the body, but they do not maintain homeostasis. All right, thanks so much for doing the notes. See you guys next week.